Hi guys, hope all doing good. Today I am going to give a small demo on one of the small topics in fluid mechanics regarding pressure measurements. When it comes to definitions, many are very confident, but when it comes to problem solving, they get confused about what is vacuum pressure and what is gauge pressure and what is absolute pressure. So in this demo, I will brief up about all the three definitions, their correlation, and then we will solve a small example to clarify regarding the topic. Absolute pressure is the actual pressure of the fluid measured with respect to the absolute vacuum, or you can say zero pressure line. Okay? And gauge pressure is the one which is measured with respect to the local atmosphere, a local atmospheric pressure. You have to underline this local word because in the next sum we are going to calculate, you will understand its significance. This gauge pressure is nothing but that measured values which are given by the pressure measurement equipment. And next one is vacuum pressure. Vacuum pressure is, I will describe with a diagram, then you will become clear of it. Say there is zero, this is zero pressure line, where P absolute equals to 0, absolute vacuum. Say a certain point A, whose absolute pressure is given by Pa absolute, and another point B, whose absolute pressure is Pb absolute. And according to the atmosphere or environment or surroundings there, atmospheric pressure P atmosphere do exist. When a given pressure is told with respect to zero pressure line, then that is absolute pressure. When the pressure is measured with respect to the local atmosphere, then that is gauge pressure. In this case, this Pa with respect to this atmospheric pressure is P gauge pressure, Pa pressure of A gauge pressure. And when it is with respect to zero pressure line, it is Pa absolute. Similar way, for the point B, when it is with respect to zero pressure line, it is P absolute. But when it is with respect to this atmospheric line, this is Pb gauge. Here we see that if we are taking P atmosphere as a reference, then Pb gauge is downwards the P atmosphere, which means less than P atmosphere, which means negative gauge. It's a negative gauge pressure. When we take this magnitude of Pb gauge, a positive or absolute value, we call it vacuum pressure. Understand? Let me repeat it once more. There are two references. One is standard zero pressure line and another one is atmospheric pressure, which is a local atmospheric pressure. Whenever take 2 points A and B, when pressure of A is measured with respect to zero pressure line, it is absolute pressure of A. In the same way, when pressure of B is measured with respect to zero pressure line is absolute pressure of B. Then if the same pressures at A and B are measured with respect to atmospheric pressure, they are called gauge pressures. But in case of A, which is above the atmospheric pressure line, it is a positive gauge pressure and we will take it as it is in the calculations. But for point B, which is below the atmospheric pressure, it gives negative gauge pressure. To avoid this negative value, what we will do is, we will take positive or it is magnitude of this gauge pressure and name it as vacuum pressure. So always remember, vacuum pressure of any point equal to negative of gauge pressure. Whenever we incur the word vacuum pressure, then keep in mind that it is below atmospheric pressure. Okay. Now one more thing to note is, from the above we can conclude that gauge pressure, depending on whether it is above atmospheric pressure or below atmospheric pressure, can be positive or negative, but absolute pressure will always be positive, because there is 0 is the last and least value that pressure can reach. Below that there is nothing, no value. So absolute pressure is always positive. Gauge pressure can be positive or negative. Whenever it is positive, we will take as it is. Whenever it is negative, we will call it as vacuum pressure and say only the magnitude of the gauge pressure. So to clarify this, let's do one small problem. Hope it is clearly visible. The pressure gauges, here this is the system given in which two compartments exist, compartment 1 and compartment 2. Each compartment again attached with one individual gauge pressures, pressure gauge 1, pressure gauge 2. So here what the question is asking is, the given data is gauge pressures, gauge 1 and gauge 2 are given as 5 bar and 1 bar. Now what he is asking is, what is this pressure? How to find it? Generally, standard is, what is P absolute? P absolute, from the above diagram, earlier diagram, P absolute is, first of all, we will add P atmosphere, local atmospheric pressure, then again the gauge pressure. From here, if we write that in formula, P absolute equals to P gauge plus P atmosphere. You don't get confused this P atmosphere with our environment, which is 1.01 bar, which is not always correct. This P atmosphere is the surrounding pressure in which this gauge, pressure gauge is placed. Okay, so for compartment 1, when we try to know the absolute pressure of compartment 1 means gauge pressure of compartment 1 plus atmospheric pressure for the compartment 1. For compartment 1, as this pressure gauge is kept in the compartment 2, that means this gauge pressure for compartment 1 is measured with respect to atmosphere, its atmosphere, that is pressure to P2, implies P gauge 1 plus P2, because P2 is the environment of this first gauge, pressure gauge. Now how can we get P2? Again further, P gauge 1 plus this P2 absolute can be obtained from its gauge pressure plus its the environment pressure in which gauge 2 is placed. So P gauge 2 plus P atmosphere of second gauge pressure gauge, which is equals to P gauge 1 plus P gauge 2 plus this atmosphere. This gauge is kept in open environment, which is the our surroundings. So this directly you can take 1.01 bar. Okay. Now what he has given, pressure gauge 1 reads 5 bar and pressure gauge 2 reads 1 bar. Then plus 1.01 bar, which will give you 5 plus 1 6 plus 1.01, which is 7.01 bar. Hope you are clear with the concept.